Hey everybody, this is Larry. This is the 3rd of December. Hit the like button, subscribe button, join me on Discord. Let me know what you think about today's farm. Maximum product sub array. Yeah, and going to be doing this all month. Come to Discord, post your problems or post your solutions. Maybe post your problems. I don't know. And ask for code review or do code reviews. Let's support each other. Anyway, today's farm is maximum product sub array. So, okay, given the numbers, find a contiguous non-empty subarray within the array that's the largest product, and then return the product. Okay. So yeah. Okay. So we want a contiguous subarray. And then we want something that is non-empty, right? So I think for me, the way that I would approach this is kind of by what I call case analysis, and case analysis. What I mean is that just thinking about how do you say this? Thinking about the different cases and the possibilities, and then try to just break them down and take the best one out of those things, something like that, right? And okay, so then one is that we always want positive numbers for the most part. There's a little nuance there, but basically you want the tricky part is negative numbers, right? And we want even number of negative numbers. So if there's odd number of them in the thing, then there are a lot of cases. It's a little bit tricky, but yeah. Maybe there's a. I think that's one way to approach it. There's another way that I can think about it, which is dynamic programming. I think there's a. I don't know if it's a easy dynamic programming, but it is a reasonable dynamic programming where basically there are only two. I think the zero. So I'm pausing right now because I know that there's a zero case, and zero kind of makes things a little bit trickier, as well. So I'm just thinking about what's the best way to handle the zeros, right? Okay, so I mean, when it comes to zeros, then any answer that contains that, or any possible candidate that contains that zero will be zero, right? So I think I'm going to do a couple of things. One is split everything by zeros, and then the sub answer will be one of those answers, right? Or sorry, the answer will be one of the sub answers of those subcomponents, and then we take the max or zero. So then now we have smaller problems that doesn't contain zero, right? So then now we break it down from a max product that might contain zero to a max product that does not contain zero. I think that's a reasonable thing, because you don't want to cause zero boundary, and if you do, then it doesn't matter how many things are in it, it's just going to be zero, right? Okay, so then now for each component that does not contain a zero, what happens, right? Well, if the even number of negative numbers, then we're done, right? We're just greedy. If they're odd number, what happened? Well, if they're odd numbers, that may be a little bit trickier. I think there's a couple of ways you can do about it with respect to breaking it down case analysis, but maybe this is the case where I'm trying to think the dynamic programming and whether that makes sense, but because or maybe there's just something like more obvious. Can we do okay, so let's say there are no zeros, and now there's odd number of negative numbers, because if there's even, then that's good, or you're done anyway. Well, if there are odd number of them, is that true? I'm trying to think whether that's true, because there's the existence of one as well. So the longest subarray does not necessarily mean the maximum product, right? And then we have to think about how to divide them in a good way. Um, Maybe that's not so bad. Maybe we can think about, okay, so let's say we have consecutive, like we have, let's say what happens, or I'm just trying to think about what happens when you divide this subproblem into even more subproblems that doesn't contain negative numbers, right? So all the positive numbers, you can group them together and just get the product of those. That seems like a straightforward thing, because greedy, right? And it should be correct just because you always want. So then the question is, which of the maybe, I guess in that case you always want more negative, right? As long as it is, yeah. If the odd number of things, I guess the case that I'm trying to think through is whether, so you have some odd negative, odd negative, odd negative, dot dot dot, right? And we group all the odds together, or we group all the positive numbers together, so we only have negative numbers. I mean, of course, let's say there's 5 of them, which is an odd number. My thing that I'm trying to think whether greedy is works is that whether the answer is always one of these two, or does it, or is there a possible answer that isn't this, right? And I don't think that there is, just because of the greedy, right? Because you always want more positive numbers, of course, and then you always want more even number, even number of negative numbers. So that means that there's no. I think that's the case. Because let's say there's another weird way of dividing it. You have just use the one in the middle, right? This cannot be bigger than, well, and you can only choose one of these because you divided by in the middle. By definition, this answer is going to be smaller than this answer, and this answer is going to be smaller than this answer. And I think that completes the proof, right? That, I mean, without loss of generality, I think that completes the proof that this greedy is enough. So let's get started. I think we broke it down. I don't know. If I have to assign a probability, I'm probably not, maybe not that much, to be honest. But like, I don't know, like maybe I have like a 90% confidence right now. Just because I might miss something. It's easy to miss something when you do case analysis. I think that's the kind of the tricky part about it. And some of those subcomponents have greedy, which also makes it a little bit, maybe 90 is a little bit high now to think about it. But I think but I'm also reasonably confident, more than normal. So let's get started, and that's how it goes. And this is of course going to be linear time because we just break, at least at worst we do 2 passes to break it into all the components, and then that's it, right? 2 or 3 passes, say, and then we just get the best answer of those. Okay. So first let's just say we tokenize the zeros. So let's group by nums. I forget how group by goes. Let me look it up real quick. Is it called a key? Is that what the tools called by key functions? So yes, then we can just group by whether this thing is equal to 0, right? And that should be good. Yeah. Let's see how that want to represent it, right? Let's just do for A, and then the group in maybe this is wrong. I mean, this is right, but I always forget. I always miss something. All right, let's just run it real quick. Okay, so this is the whether this is 0, and then this is just a list of items. So okay, that should be good. So then now, if z is equal to, if z is true, that means that there is a 0. Then that means that so best, let's say negative. We start with some negative, really big negative number, and then if 0 exists, then we set it to 0 if it is bigger, and then else if it is not 0, we try to get the better answers of it, right? So max or best, and then let's just call it go for now, and then list of g, and then return best. Let's call it get max product without 0. That's a very long name, but that's fine because we have the magic of copy and paste, and then we have a list of array, right? Let's print it out real quick, and then return 0 just for return, and then we can make sure that doing the right things. So that is right here, but let's do one with 0, obviously, and maybe just construct another one. Oops. Sticks were made. Yeah, so that looks good. That it is what I expect. So that's good. And then now we do the negative numbers, right? Okay, so let's see. Yeah, okay. Yeah, I mean, let's do what we said we're going to do, which is that, yeah, let's just count. I mean, there are actually a number of ways you can implement this. I'm just going to implement it as straightforward as we said earlier. So let's just go negative is equal to 0 for x in array. If x is less than 0, negative we increment. And if negative is mod 2 is equal to 0, then which means that we have even amount of them, then we can get the answer is equal to 1 for x in array. Answer oops, and then return answer, right? And then otherwise we have odd number of negatives. Then what? Then we tokenize it. No. What we said is we'll take all the numbers. We'll take all the numbers after the first negative, and then we'll take all the numbers before the last negative, right? So okay. Okay. So this is a little yucky, but let's just say first index is equal to, is there like a first function in Python? I actually don't know. Like first that next maybe? I don't know. Python first function. First function, is that right? Oh yeah. Oh no, you have, there is a thing in, so you have to install something called first, which is not, okay, fine. Let's just write out the loop. So that means that there's an odd number of negative numbers. That means that these things will always exist, right? So that's me just going over the precondition. Oops. If x is 0, first index is equal to I. Let's also do last index then. We're in the same loop. This is a little yucky, but that's okay. So last index is always equal to I. Here, only if first index is none, right? And then now we can return max of two things, right? Product. Let's also call this product because that's what it is. So product from and since first negative, and then product to last negative maybe. And maybe this is from. Okay, so then let's start with is there more case? I think this could be a case in that this is actually this if let me think about this for a second, right? Because basically with the input, let me put in that input so that I don't forget about it. If the input is just -2, or even maybe okay, let's do that. But also even if it's just this, no, then there's a positive answer. Okay, so it has to be just one element. I mean, let's put that one in anyway. But okay, because we in this case, then this is 0, right? So the first, what happens to the first? Okay, then we just get the rest of them. But the thing is that you can, in that case, you cannot have sentinel equals 1 anymore, right? I think that's the worrisome thing. So, for example, we do something like, okay, maybe I can just fix that if statement. But what I was gonna say is, if we do something like first index plus 1, something like this. If we do something like this will have an empty array for that empty thing, and then you would return a 1 where it actually is a no answer, right? Because you don't add any, or you don't multiply. There's no product because there's no number. So I think that's the worry that I have. And then the way that I would think about it is just have an if statement, right? So if first index is equal to 0, then if the first index is equal to 0, what does that mean? This is annoying, actually. Let's think about it. But basically, if the first index is equal to 0, or actually that's not that bad, but it's worse if the first index is the last element, because then this product is going to be undefined, right? And in this case, maybe what you use is just a negative number. So, okay. So if this is equal to n minus 1, where n is equal to the length of this array, if this is the case, then product from first negative is equal to okay. So that I thought it through, and I think this is correct, but I just want to kind of talk through it a little bit. But basically what I'm thinking about is that I'm going to set this to be just a number, which is the negative number, right? Which is R of first index in this case. And then we'll compare this to the max here. And the reason why this works is because there are only 2 scenarios, right? One is that first index is also the 0th index. Then this is just going to be the number, which is fine, because then you use that number anyway. But if there are multiple if it's not the first index, or if the first index is not 0, then product to last negative will contain so you only have one negative number, and that would contain some positive number, so then this gets ignored anyway, right? So that's basically what I wanted to say. So yeah, okay. Otherwise we do this thing from the first negative, and I think that we should be good. Okay, and then we do the same thing for last index. If this is equal to 0, then that means that there's only one element, and then also product to last negative. Let's just set it to the array just as a sentinel value, and then we do the other thing, right? We do this thing, but the other way. I always forget whether this is inclusive, to be honest. Really bad about this in Python. Like I mess that up all the time. So we have to take a look. What, to last negative? Whoops, we don't want to return it. we just want to go to this thing. I always forget whether I'm so bad at this. Okay, so print okay, so no, not negative, just to do it. Oh, whoops. What's it called again? Nums. Sorry, friends. Gotta do some checking, and then I'm gonna take a nap. But how does this get accepted? Why would this not? Oh, because this returns no if it's too small. Okay, so to 3. So this is not inclusive. It seems like, right? So that's. So then that means that the other part is good. Okay. Because this means that it doesn't contain the last negative, which is a negative number. Okay, so let's give it a go. Like I said, I'm not super confident. But let's give it a spin, I suppose. Last time I took 2 attempts. Yay! This time I got on the first go. I'm happy about that. Day 612. Look at that streak. Don't like that they keep on. I've done this in the other thingy, so it's a little bit whatever. But cool. Let's see. So yeah, my advice for you is to kind of just break it down to cases, do case analysis, and then do the best you can. Some parts of this contains greedy, which is maybe a little bit more intuitive in the sense that if you multiply numbers, you're only going to get bigger, except for negative case. So yeah, I could very much see this as an interview problem. This has already it doesn't require anything hard. Per se, there's no oh, you need to know this algorithm, right? It's just it's very basic in that way. That said, that's not to say it is easy, because there is a lot of you have to really think it through, and you have to have some experience playing around these things. Maybe I mean, you don't need it, but it'll make it go faster. So yeah, this is going to be linear time, because we do 1 loop here, a second loop here, and wait, no, that's not the second loop. The second loop here, and more loops, but these are none of these are nested, so these are just straightforward loops. Technically, we used a little bit extra space because the group by will construct technically it's an iterator, I guess, but we convert it to a list anyway. So a lot of the things that we do, this makes this a linear space thing. But you can imagine that if I was not being lazy, you can do everything I do with pointers and just keeping track of indexes, and you could do that easily with because, for example, this you could just write a for loop with the indexes from first index plus 1 to last one. Here you don't technically need this to make it a list, or you didn't even need to use group by. Really, you could just keep track of the indexes using a linear scan, and then just do it from indexes, right? So you can do this in linear space, but that said, I am doing this in linear time and linear space. Just as a disclaimer, but it's not hard to do it without it. I'm just lazy. But yeah, of course, on an interview that may be different. I may not be so lazy. Anyway, that's all I have for this one. This is day 3. That's all I have. Stay good, stay healthy, to good mental health, and take care. Bye bye.